Hi, Stuart here. And today, based on some comments in the chat and some interrogatories via email, I've decided to do something a little different, non-technical, more about career development, and just call out some architecture things, some basics I think every architect should know. This is by no means a comprehensive list, but what it is just some things to think about. One of the things that happens is if you get two architects in a room and you ask them what architecture is, you'll get three different answers. But fundamentally, what architecture is about is a set of design and guiding principles that help you deliver a system. We're going to use these technologies and not those. A lot of my job as a solution architect or a platform architect or an enterprise architect is deciding what we're not going to do. I tend to be very open-minded about all the technology choices there are out there. And then I look at the non-functional requirements and I look at other factors and I say, okay, what is the best fit for and I include the iron triangle, right? The iron triangle being I have to think about cost, I have to think about resources, and I have to think about time. So it's a balancing act. And if you as an architect can deliver something that does what the business needs, and it's kind of an 80% solution and you're sort of grumpy about it, you're probably in your sweet spot. Because the Pareto rule absolutely works in my life experience. The first 80% takes 80%. The second 20% takes 80%. So knowing when to stop architecting is a good idea. And architecture is more important the bigger the system is. So if you look at a system and it's going to have 5,000 concurrent users and it needs to run in a bunch of data centers and it's going to run in the cloud and things like that, then you need to invest a lot more upfront in architecture. And the trouble with a lot of projects is that despite the overwhelming statistics that show the value of investing in architecture first and having an open and thorough discussion of the pros and cons of different approaches being huge, both time and money savers down the road, time is money, a lot of projects just sort of go, well, it's the cloud, let's just throw some things up there. And that leads to grumpiness because things work until they don't. You get to a certain scale, you get to a certain complexity or a certain number of transactions, and all of a sudden your system that is tossed together like a salad stops working. So investing in architecture is a good thing. And being an architect is a very heavy responsibility because you are spending or planning to spend the business's money by the handfuls. And what they need is for it to deliver more value than it cost. And then it needs to be economical to operate long term. How to judge architectures. Fitness for purpose and fitness for use. Fitness for purpose, of course, is does it meet the business requirements? Fitness for use is, is it sustainable from a technology point of view? Some people also use that to include, do the users actually like the darn thing? Requirements conformance, abilities conformance, all of the good things that we look for in architecture. I'm just going to put a stake in the ground and saying architecture and DevOps go together because there's no point in architecting something that can't be developed or operated cleanly and successfully. And every time I've seen a project that didn't invest enough in architecture, not just at the beginning, you don't bring an architect in for 4 weeks and then pat them on the head and send them on their way. Architecture is a beginning to end thing because most automated systems have very long lifetimes, but they evolve constantly. And as they evolve and new technologies appear for problem solving, it's the architect role that goes, it would be beneficial to this system to do this migration or do this change or whatever. And they can make that business case. There are lots of good videos on managing up and communicating to C-level people, and I encourage architects to develop that soft skill, because you will win no arguments until you learn diplomacy first. This is a list of some of the things that architects do, and this list speaks mostly to once the project is underway, or just getting started being underway. And these are some things that you should do. And there are things I almost always do. If you're talking to someone and they claim to be an architect and they can't code and they don't know how the DevOps tools that the organization is using works, what they are is an architect on paper. And they'll be a lot less useful than someone who can jump in and troubleshoot something that's going on in the environment. Often architects are called into the troubleshooting or incident support role, and the good ones are able to deduce very quickly what has gone on. And in some cases, they put their hand up and go, okay, that didn't work like we planned. In the short term, we're going to do this. In the medium term, we're going to do some refactoring. And in the long term, we're going to start shopping around for a different component to do this thing, because it's clearly not doing the thing we want it to do. Ultimately, you're the person. Now, you may be the person in concert with some other the persons, so that there's some collective ownership. But at the end of the day, the architecture group is responsible for the technical delivery. So you need to work very closely with all the different roles on the project to help get to there, right? If you're an architect and a dev pops up and says, look, I don't understand why I'm doing it this way, or I don't know how to make it go, that is a sign that either what you have asked them to do is insufficiently clear, or that you, as an architect, owe the team some education, right? Okay, you may not have seen this before, but this is why this works like it does, and here's some gotchas, and here's some sample code. I write sample code for people all the time. I write lots of libraries in the form of NuGets and reusable chunks of code and NPM packages and things like that, because if I can encapsulate an interface to, say, Azure Service Bus in a way that is repeatably correct, then I have a huge lever to influence the positive outcome of a project that has a lot of messaging in it, and so on. So, warning Will Robinson, if your architect can't code and won't help troubleshoot, maybe they're not so much as an architect as they are a paperweight. The thing about architects, all of the good architects I know have extremely good critical thinking skill, because an architect who has never seen something before, technology, or never seen a particular problem domain before, who has strong critical thinking skills and is given a base of information, can then reason about it in the same way that a logician can posit an ocean from a drop of water, right? That ability is all about critical thinking. And time that you spend as an architect or someone who wants to be an architect, developing your critical thinking, separating your emotions from the data that's there and drawing inferences from it, is critical to success. And the other thing about critical thinking is you don't fall in love with your own ideas. You may pat yourself on the head after your good idea works, but if it doesn't work, you have to be ready to go, okay, what would be better here? And that's all about both professionalism and critical thinking. So time spent developing critical thinking skills is worth doing. So there's some foundational sort of acronyms and global patterns to architecture that is sort of the key takeaway. And at the end, we're going to recapitulate some things about DevOps. I want to start with SMART. SMART was developed by George T. Doran. And for a long time, Six Sigma and TQM and lots of other things tried to boil down how to judge a goal. And they had, herringbone charts and flow charts and these reasoning things and matrices. And it turns out that a little critical thinking and some nice writing by George Doran made it pretty easy to understand for everybody. And he came up with this acronym, which is very clever, called SMART, which is, particularly if you're reading a user story or you're reading, requirements document or whatever, are the things that they're asking for specific? Lack of specificity is a warning that the problem is not defined or not well thought out. You have to be able to measure what success is. There's a famous management slogan that has been beaten into everybody of a certain age, and that is, you cannot manage what you do not measure. So it shows up in Six Sigma, it shows up in TQM, it shows up in BPM, it shows up just everywhere. And it's absolutely true. But you can't let the measurements become the goals, because otherwise you'll simply deliver to the metrics. And that's not the same as delivering to the needs of the business. So while you need something to be measurable in the area of, did we fulfill these specific requirements? And by the way, in order to test that, the requirements have to be specific, right? You need to be wary of delivery by metrics, because that is an anti-pattern. Although it can tell you useful things. Don't be so enamored with it you don't do anything else. Actionable, in other words, somebody has got to be able to do the thing. Relevant is, there has to be a reason we're doing this thing in the context of the system we're trying to deliver. And obviously you need to have some estimate of how long it will take and/or the resources required. So when he talks about time bound, he was doing it more in a business context. As people who deliver systems, we have to throw in actually the entire iron triangle into time bound. And it's that blend of money, resources, and time. And so SMART has made everyone's life a lot easier for the people who followed it, because now we have a set of easy to understand criteria that everybody on the project can, if they're going to object to something, then their objection should be in the form of this thing that we're talking about didn't meet the SMART criteria in the following ways. And in fact, if you have a requirement that's just wrong, then the problem is that it fails both specificity and relevancy. So pretty much everything falls into the SMART acronym. I try to teach it everywhere I go. I try to get people to think that way. It's part of critical thinking, I think, and it's extremely useful. So then here's something every single developer on planet Earth should know. And it's one of my favorite interview questions. Pick one and I ask them to tell me about it. And if they don't know what S.O.L.I.D is, I have doubts about them. This is every bit as true as the day it was coined. These 5 principles apply at all levels of granularity to building big complicated systems or really simple ones. In other words, this is an idea that has scale and breadth. And you can go read up on S.O.L.I.D on the interweb. The Wikipedia's got a very nice article that talks through it. There's a nice discussion of C# and S.O.L.I.D on the Microsoft documentation pages. But you should know and live this thing, because S.O.L.I.D is one of the ways that we judge chunks of code of any size, from all the way down to a function to all the way up to a subsystem, right? We go, does this really follow the S.O.L.I.D rules? And it turns out that if you are into domain-driven design, which we'll talk about in a bit, and I have a almost 2-hour video, it's an introduction to domain-driven design. That really dives into it. You'll find that nothing in domain-driven design conflicts with any of the other rules I'm talking about. And especially S.O.L.I.D is relevant as a mechanism to ask the question, have we put this entity in the right domain, and do we have separation of concerns that are reasonable, and so on. The 12 factors are relatively new compared to S.O.L.I.D, but if you are building anything that runs on a network where there is more than one deployable unit, even if it's something as simple as a UI in a database, you should probably think about the 12 factors. And you can go to 12factor.net and you can read all about them, or you can watch all 12 of my videos on 12 factors. But as an architect, you should know, believe, and absolutely focus on these. 5 of them are non-negotiable as far as I'm concerned. I call them the Fast 5. And it's what I look at when I'm evaluating a code base is I look at the Fast 5. And if any parts of the code base sort of fail the Fast 5 parameters, I go, we're going to have to do some work here. Configuration is particularly heinous. We'll talk about that in a minute, but disposability is a big deal too, because one of the reasons that containerization projects fail is that the startup and shutdown of your process in a container is 2 orders of magnitude faster than platform as a service, which is an order of magnitude, 2 orders of magnitude, or even 3 orders of magnitude faster than if you're on infrastructure as a service. Disposability becomes a big deal because the container will come up and ask, is this thing live and ready to receive work? If your thing is still starting or still shutting down or whatever, it's not crisply up and down, you're going to have a heck of a time containerizing it with any kind of reliability. And that's just one example. You can go and watch the videos. Lots of good stuff in there. I have an allergy to cool. I have an allergy to patterns for the sake of patterns. Don't get me wrong. I love patterns. I have half a dozen pattern books. I reread the big Martin Fowler one a couple times a year. I refer to it all the time. But I keep hearing particularly, and I don't want to throw a particular age demographic under the group, but people who are less experienced tend to gravitate to something that's cool. They see a presentation about something and it's really compelling and it's going to be great resume candy. And they say, we've got to use this. And my question is, I agree, it's cool, but how does it fit into the overall system? And are we adding something for the sake of adding something? Less is always more. So domain-driven design, we talked about it briefly. Here is the book of books. I have a whole micro course, an introduction to domain-driven design, and you can go read that. And if you have not read this book, it will change your life. It is simply awesome. The other one that I found that was really helpful is in the same Martin Fowler series from Madison Wesley. It's about evolutionary database design and about evergreen. And Scott Ambler's book now is getting a little old, but the ideas, if not the technology that he refers to, are still every bit as valid. And in fact, if you were a fan of Earl, who wrote a whole bunch of stuff about S.O.L.I.D design patterns, and he's got brick thick books, they're excellent, but they're trying to say the same thing, that versioning is important and that isolating the consumers of data from changes to the underlying schema is important. And how to do that is, practically speaking, is in refactoring databases. And it's a terrific book. Microservices. I have to say that most of the implementations of microservices that I have seen are distributed monoliths because they are not truly built to be independent of each other. And there's a certain purity test. If I see something that someone says is a microservice, but I think that their implementation is both practical and reasonable for the scope of the system they're building it for, I'll say, I don't think that's a microservice, but I do think it's a good service. And I'll point out that microservices are not the be all and end all. Microservices are a good thing when used properly. That rule is about use cases. If the use case for whatever pattern or technology that you are trying to use or thinking about using is a good fit to the requirements of your system, the architecture of your system, then it's a good thing. Patterns are good. Reusability is good. But beware of the converse of coercing something to be canonical just because that way you have one less data structure or one less execution. And so it's a balancing act, right? There is no perfect answer. While reusability is a good thing, services, standards, protocols, patterns, etc. is a good thing, be wary of what language teachers call false friends, which is, this thing looks like that, But when you think about it, when you use critical thinking and domain-driven design, isn't in fact the same thing. They should be different. They should version separately because fundamentally they represent different ideas. So be wary of false canonicalization. DevOps is table stakes. Semantic versioning. Boy, am I sick of software that does this wrong. Semantic versioning is an overwhelming benefit because in the version in itself, the version number, it tells you everything you need to know when you are adopting it. But it means that people have to use it correctly. What's a perfect development flow? Well, this is my model of a perfect development flow I inflicted on all the project teams I work with. And that is, you have a backlog, peel off a story, you make a feature branch, you do your development, you do a pull request. That results in peer review. If they agree what you've done is good, then it goes into a CI build automatically, which results in a set of build artifacts that then can be deployed at will separately from the development cycle. So when the QA is ready to QA it, or the business is ready to do user acceptance testing or whatever, they can cause it to be deployed to an environment and use it and give you feedback, which of course goes into the backlog. It is what we call a virtuous cycle. So what's in a good build? Well, there's something called the build W, and this is it. And these are roughly the steps that you would take. Now, obviously, as your languages and platform changes, some of these are going to change, but the ideas and the order is reasonably immutable because you want builds to fail fast. So do a build of some variety. Static code analysis tools are available. There are lots of expensive paid ones that do lots of many good things, but that should not deter you from using one of the open source ones if you don't have the budget. Ditto security scanning tools. And then you want it to run unit tests. I won't get into the argument about whether or not you should do test-driven development or test with development or whatever. But I'm saying have some tests and have a metric about when code is added to the code base, the number of tests should grow and the code coverage should stay the same or get better. And then obviously we have versioning, packaging, storing, build artifacts, and the output of all of these steps. That's the build W. And you can probably rearrange some of these steps and you can probably add things to these steps. But this is what I consider to be the minimum virtuous CI build. It's really important to have integration tests. They're useful for a bunch of reasons, and we'll talk more about that later. But if you don't have any automated integration tests or indeed automated testing framework as part of your project, you're adding a lot of risk, uncertainty, and dramatically increasing the chance that your system will have undocumented and horrible problems. So what's a perfect deploy? Well, perfect deploy is I go get my build artifact and I write it to the host. And here the host could be anything. It could be a virtual machine, it could be platform as a service, it could be PCF, it could be Kubernetes, doesn't matter, right? The pattern is the pattern. And into the host, we inject some environment variables. For example, a bunch of information about the host itself. But the key thing that we need to inject is where do I get my secrets and configuration from? And this is the magic that allows you to separate your configuration from your code. And on startup, your processes the environment variables and then calls out to secrets and configuration as needed to go get information that it will need, like where's my database, where's the storage, and so on. Perfect deployments, and the advantage to having your secrets and configuration externalized is that you can manage and audit them, and there are lots of great tools for that. I love HashiCorp Vault, but there are plenty of other good ones, and I have a nice demo of using HashiCorp Vault as configuration and secrets management, and you can go play with it. Monitoring management, have some. From our hosting environment, we're going to get streams of logs, we're going to get events, and we're going to get state. What's the difference between events and state, you ask? Well, An event is something the hosting environment raised to you. State is something you read about the environment, like how many instances of this application do I have, versus an event, which is, haha, I've run out of disk space. So then you have a set of tools, and again, there's tons of open source and commercial tools, and many of the commercial tools have an open source version, so you can try before you buy, and then when you're at a maturity level where the paid version would offer your organization a lot of value, then you can adopt those. But you should try to stay as close as you can to what the hosting platform exposes for you. And then you want to have this pattern where the monitoring platform separates out the wheat from the chaff, the stuff that needs action from the stuff that does not. And in really modern systems, the monitoring platform actually attempts to do an auto repair, so it doesn't have to create an incident. An incident means that something has gone wrong so badly that we need to get humans involved. So we generate a ticket, and obviously it needs to be smart enough not to make a ticket for the same incident over and over again. And then you need a notification and escalation tool so that the humans know that there's a problem and that you need to come along and do something about it. This is kind of the high-level architecture of monitoring and management. And you can get very, very sophisticated with these. And all of the major cloud providers have good basic tools to get you started that are part of the platform. And then there are plenty of good third-party products as well. We talked about earlier about the need to have visibility into what your system is doing to know if it actually works. And this is the subject of synthetic transactions. It's more than just monitoring. It is proactively having an automation that pretends to be a user and does things a user would do or a consumer of your API would do. And it sees if the goal can be achieved. So, for example, if I have a shopping system, it would try to cart up some stuff and create an order. I might have a different one that checks to make sure the order processor is correctly processing the order, and so on. And in some cases, organizations that are very sophisticated extend these into the real world. There are plenty of e-commerce sites that actually generate synthetic orders that get shipped to places that are then inspected by people, and they can say, well, this box was packed correctly or incorrectly. It had the right stuff in it or it didn't. So synthetic transactions can cause real world or, in the world of atoms, consequences. But at the very least, they should focus on the goals of the system, the business goals. Developers have tasks, but users have goals. A long time ago, a bunch of friends and I got together and said, wow, there are a lot of non-functional requirements. And we looked at TQM and Six Sigma and all these other systems. And we said, oh, a lot of these are synonyms for each other. A lot of these are overlaps of something else. As an exercise, let's see if we can boil down all the non-functional requirements into the smallest list possible so that a particular non-functional requirement can be tagged or associated with one or more of these abilities. And notice here that instead of attempting to do a hierarchy, right, that is super picky and hair splitting, where there's a capability and therefore it's a functional requirement and therefore we just say, hey, this requirement, which is smart, is associated or satisfies one or more abilities, and here is the tag cloud of those abilities. Because then I can go through and find all security-related ones, I can go find all the portability-related ones, and I have a long-running challenge to my friends, peers, and all of you out there who see my YouTube videos or consume my GitHubs or whatever. And if you can find a non-functional requirement that cannot be mapped onto one or more of these, there is a prize. And I'll have to update the slide. It's good to have because 10 things are fairly easy to remember. It's not as easy. We tried to get it down to smaller than that. There was a lot of arguing, and we finally, is testability, supportability, and we decided no, indeed, that is not, nor is maintainability a surrogate for testability, and so on. So we came down to this 10, but this is one of those things where when a project starts and we're doing requirements reviews, I will go write these 10 things on a whiteboard, and then as we come up with where we requirements storm, I'll put a little checkbox that says, oh, this satisfies this thing. IBM used to have this commercial that there is no pixie dust. You can't retroactively put in things like quality and security and other non-functional requirements without spending a lot more money than if you'd just done it from the word go. And that's just absolutely true. Going all the way back to a great book, Software Engineering Economics, they've been collecting this data. So I want to talk about the nines a little bit. This is probably one of the most misunderstood things in which I have had just some really painful conversations. The number one rule for big systems is no single point of failure. If you have no single point of failure and you have high availability via scale out, that is, you have multiple instances of something, then any individual component generally doesn't need to be more than 3 nines, or about 9 hours a year of downtime. Because in the aggregate, you get a pretty substantial number of nines by aggregating. I'll also point out that the nines curve falls off precipitously. So you can see past 3, you're spending money, but in real human time, you're probably not gaining as much as you think there is. And there is a simple formula that you can go and read up about on the Great Reliability Wiki. That is a whole wiki about reliability. And this is how you compute the effective number of nines for a resource that is load balanced. And you can see that even though the individual things only have 3 nines, the upshot is that you end up with 4 nines of reliability in the aggregate. Thank you for your kind attention, and feel free to leave me comments and questions.